So this really annoys me.
This is not CQRS.
So let me explain you what the problem is. Say you are a developer and you just heard the term CQRS for the very first time. Now you use .NET, so what do you naturally do? You go and Google CQRS C#. And then you get a bunch of resources all telling you exactly the same thing. Whether it's blogs or videos, doesn't matter, it will tell you the following. So in order not to discredit anyone, let's take a look at what ChatGPT has to say about this. So I just asked, how do I use CQRS in C#? And it tells me that it is a powerful pattern for complex systems. Great. So what do we need to do? We need to define our commands and queries. It creates a command and query handler. We have to set up a mediator. Now this is something that may or may not appear in various resources. We create a command and query model, and then we implement the handlers. Okay, let's take a look at the code that was suggested. So it's going to tell me to create a user command. Great, and then a handler. So we inject this iUser repository, and then in the handle methods we just add a user right here. So that's my command, and then for a query we have another object right here, which is also an iRequest, and then we have another request handler. We inject the same iUser repository, and then we handle the call by returning what we had right here. And then there's a little detail right here to configure a mediate R, which is apparently the library that we are using. Okay, so I put this code into Visual Studio. Well, it's a slightly different example with a product, since ChatGPT gave me this example previously. And I have basically the same thing here. I have a command and a command handler where we inject this DB context, the product context. We create a new product, add, save changes. And then we have our query right here, another object, and we have a handler that is associated with that particular query. And now I did add this product entity and this DB context right here to complete the picture, but that's all I did. Now we're going to take this as an example for the rest of the video. So this is not terrible, this is actually quite good code, but is it CQRS?
This is not CQRS.
Okay, so to decide whether or not this can be considered CQRS, we first have to understand what CQRS actually is all about. So let's go back in time to the year 97, where this guy called Bertrand Meillet wrote a book about object-oriented software constructions. Now, this guy is not just any guy, he's actually the author of the Eiffel programming language, so he knows what he's talking about. Now, this is 97, so this means that this is the era where object-oriented programming is still quite new. So in his book, he introduced CQS, the Command and Query Segregation. Notice there's no R in here. Now, this just has to do with object-oriented programming. So let's take a look. Okay, so I have this class right here called car, and I have a query and a command as introduced in 97. So what a query is just something that retrieves information about the current object. So this getColor method is exactly that. And a command is quite the opposite. You would execute some kind of action, right? You would do something, but it typically would not return anything at all. And Meillet wanted to have a clear distinction between the two. You do either one or the other, but not both. While you are retrieving information, you do not change the state of the object. Now, I actually have been using this principle for a very long time without realizing it actually had a name. It's a common practice. Although you can write good code which does not follow this practice as well. A good example of that is this right here. I've got a stack of cars, and when I say pop, well, pop actually returns an instance of that car, but it also modifies the state of that stack. One item is removed. So this is in violation of the CQS principle. So let's fast forward to the year 2010. At that time, we are already building a lot bigger applications, and there's this guy called Greg Young, and he was looking at the CQS thing and thought, maybe we can apply this principle, but on a different scale. Maybe we can apply this principle on an architectural level, and I can separate my reads and my writes on that particular level. Because if you have a larger application, there's often a tension between your reads and your writes. They might have very different needs, and you cannot optimize for both. For example, if you have a relational database, well, that one is great in supporting complex queries, but it's not great in scaling out massively. So if you need that scale, let's say for your reads, well, then that might not cut it. So you switch to something like MongoDB. But then MongoDB is not very good at supporting complex queries, which you might need elsewhere in your application. So is there a way to combine best of both worlds? So that's exactly what Greg Young set out to do. And his proposal was to have a complete separation between a read model on one hand and a write model on the other hand. Because there might be very different needs here. First of all, the people that write are not necessarily the people that read your data. I'm going to show you an example with Amazon in a second. Of course, the people that actually supply the products are not the same as the people buying the products. So you might need different authentication mechanisms as well. Also, when you're writing, you would typically have to validate your user input. Actually, a whole bunch of complex business rules might apply when writing. While if you're reading, typically you are allowed to read or not, and that's it. On the other hand, while reading, you might often need complex queries, while typically an insert or an update is pretty straightforward. And quite typically, the data that you would return would look different. So you might support some kind of DTO to return exactly what you need. Other than that, there might be very different constraints, whether it comes to like scale or consistency and so on. So a great example would be Amazon.com. So I'm here just in a random page, and this page has to load quite quickly, right? Now there is a ton of information on this page, right? There's all the information about the product itself, but there's also information about stock and shipping. So reading has to be very quick, and it also needs to scale out massively because there are many users. While if you're writing, you don't actually need that scale. And there might be other relationships to a whole bunch of stuff we're not seeing here behind the scene. So the read model will probably be quite different from the write model here. Actually, Amazon uses microservices, and the reviews and the stock information and delivery would typically be in different microservices than the product information. So you don't want to go and have to query like 17 different services to create this page. No, you want all of that data ready to go so it can be read immediately. So the way that Amazon might solve this is by introducing one database here for the write model. For example, SQL, which has great consistency. And then for read, we might need something different. Let's throw in MongoDB, for example, which scales up massively. And we just put everything that we need in there, so the product information, but also the reviews, also the shipping and billing and all of that information in just one place as a simple JSON document ready to go. So we can write our stuff here, applying these complex business rules, and then we can read this massively scaled out Mongo database right here. Now, of course, one of the issues is consistency, because whenever I make a change here, that change needs to apply here as well. So we're going to need some kind of mechanism to update this database when this thing changes as well. Now, in cloud architecture, what you would typically do is you would throw in something like a AWS Lambda, or if you're working on Azure, you could use a function app. You don't have to use cloud per se, but this is what is available to us. Now, this does come at a price, because that means if we make a change here, we're not going to wait until that change is propagated before we return a success here. That would be too slow and would kind of defeat the purpose of separating that read and that write. So we just write here, we immediately return, and then asynchronously we're going to update this database. So that does mean that you'll have to be able to deal with eventual consistency. It will not be immediately up to date. Here it might take a little while. Another example could be a ticketing system. So for a good ticketing system, you would need a lot of writes in a very short amount of time. So what people tend to use there is use some kind of event sourcing mechanism. So event sourcing is an append-only store. This means that you will never have conflicts. You don't need to log anything because of updates and deletes and so on. You only append to that data store, which is great for simultaneous writes. However, it's a nightmare to read from, so then maybe in your read model you can just slap on a regular database or maybe even something like a Redis cache. So if you take a look here at the AWS documentation for CQRS, this is exactly what you're seeing. We have a write API going to a write database, we have a read API going to a read database, and we have these events synchronizing the data between those two. They also give an example right here where they use DynamoDB, which is great for lots of writes, and then we have a more SQL-like database with Amazon Aurora, which supports complex queries in this particular case. Now, things don't have to be this complicated always. If we take a look at the documentation here for Azure, you basically see the same story. And here you do see two physically separated databases, but they also give examples where you just have a single database, but within that database you have a separated read and write model. Probably they don't have any scaling differences between read and writes in this particular case, but you don't have to push it to the extreme immediately. You can make this a little bit simpler. At the very least, you will need like a different user with different writes for your read and your write model. Also, the example that I gave you with Amazon uses microservices, and you may have heard of event sourcing and domain-driven design whenever CQRS comes up. Well, those things are not necessarily related. They're usually within the same conversation, but you don't need microservices or domain-driven design or anything like that. CQRS is a principle that stands by itself. Okay, so let's go back to the code that we started with. So first of all, CQRS as an architectural principle doesn't really care about the code details at all. It doesn't even care which language it was written in as long as you follow that principle. Now, if you take a look at the code, then you see that this command handler simply talks to your DB context, and then this one, the query handler, does exactly the same thing. So you're talking to the same tables of the same instance of the same database, probably using the same credential. This is not CQRS. Also, if I take a look here at my command versus my query, well, there's not a real distinction between those two. I can just rename this command and everything would still work. Two commands are just as separated as this query and this command, so we need a little bit more on that front as well. So to answer the question, is this CQRS? Well, the answer is clearly no. However,
This is not CQRS.
So CQRS, as we just discussed as an architectural pattern, has a couple of downsides, the major one being its complexity. And that's why a lot of people, when they want to use CQRS, they're in doubt and say like, okay, maybe we can postpone this decision and only add it when it becomes necessary. But in the meantime, let's already prepare our code for the eventuality that we want to use CQRS. And this preparation of code is something that people started to call CQRS as well, which I absolutely hate. So now you kind of have two flavors of CQRS. You have the architectural pattern and you have the design pattern. So let's take a look at our code and see if this is CQRS, the design pattern. So the main issue I have with this implementation is that it does not clearly show what a command or a query should be. So this next part actually applies to both the architectural and the design interpretation of CQRS, let's say. And let's talk a bit about what it really means to have commands and queries. So this thing right here is a command, but it is more like a CRUD operation really, right? We have create product, we have update product, we have get product, right? So all of these things are just representing CRUD operations right now. And I get it, it's probably just because of simplicity's sake that they use something like this, but it doesn't really show you what a command is. Think of a command more like an action, something that you want to do and not something that matches a certain entity in your database. So what does that look like? Well, I have a couple of examples right here. So indeed, we could have things like create product and delete product. These commands align with CRUD operations, and that's fine. Yeah, you will have some of those. But you can also make it a little bit more interesting. So the one that I would not recommend is this one, update customer. If your customer has lots of properties, then the handler of this one has to compare each and every one property, and if a certain property changes, then apply these business rules and so on. So a lot nicer is actually this. The thing that your customer wants to do is update their password, right? It's very straightforward. You have to update one field and you know exactly which business rules you have to apply. For example, your current password must be different from your previous password, right? And same thing for address. If you update your address, well, we're not just going to replace your address, we're going to keep your old address as well, right, for previous shipments and so on. So we're actually modifying multiple tables at that particular time. Now these two are still quite closely aligned to simple CRUD operations, but it doesn't have to be like that at all. For instance, this one, send invoice, is completely different. Yeah, I probably need to update a couple of things in my database and indicate that this has been sent, but that's not the goal, right? I want to send the invoice. And an even more complicated example than that is process order. Here you can see an entire list of what I'm supposed to do when processing this order. So you see that this is not aligned to an entity at all. It is something that we want to do. It is an action, and whatever the result for your database is, well, we'll just have to deal with that in the handler. Using commands typically helps the design of your application as well, because if you just have an API that exposes CRUD operations, well, look what happens. I have my API, I do some CRUD operations to my database. Fine, but where are my business rules? Well, if I need to orchestrate a bunch of things, if I need to update multiple things, this will happen before entering the API. So you probably get something like this, right? Your business logic is actually external to your API and maybe scattered all over the place. Well, if you use commands, it will probably look a bit more like this. So in this particular case, your API receives a command, it sends that to the handler, which will apply any business logic that is required, and then does any CRUD operation which might be necessary in your operation. So you can clearly see that this leads to a better API surface. We worry about commands, things that need to happen, and how this is implemented can easily evolve in the future. While here, every time you make a change to an entity, your API changes, and this needs to change as well, and this might be deployed separately and yada yada. So that's not a lot of fun. So generally speaking, I prefer commands over CRUD operations. You don't have to do that per se. If you have a simple application, CRUD operations will work just fine. But if something gets more complicated or potentially will become more complicated in the future, commands are actually quite nice. Now the same logic applies to queries as well, where the result of your query does not need to match an entity of your database as well. And that's where we typically end up with DTOs, these data transfer objects that contain all sorts of information that handle your need just fine. Generally speaking, I noticed that most people don't really struggle with the concept of queries and DTOs, but then for commands, yeah, most people still write stuff like this and never write stuff like that. So I just really wanted to emphasize that. Another thing that I like to do, by the way, is I like to be very explicit about what a command is and what a query is. So unlike the previous example, where my command was just an I request, in this particular case, my command is actually an I command. And this is more of a marker interface that just clearly says, hey, this is a command, while I also have this interface for queries. So there's a clear distinction between those two. And then you can start doing interesting things. For example, in my I command, I could add this validate method. So every command should be validated before I even send it to the handler. This could be done, for instance, here I have this pipeline behavior which only applies to commands, and right here we will call this validate method before handing it over to the validate method. This is just a simple example, of course, but it could give you some ideas.
This is not CQRS.
So to answer the question, is this CQRS? Well, from an architectural point of view, definitely no. From a design pattern perspective, well, almost. And actually the example that was given here was actually a lot better than the example that I got yesterday, because it does in fact explain what a command and a query is, and it tells you to create separate models, right? It's not really clear in the code that I've got, which is a shame. But of course, people try to make things simple, but as you make things simple, you might oversimplify things until there's just a point where, you know, the most central concept, which is commands and queries, doesn't actually come across. So is this CQRS? My answer would be no, but it does hint you in the right direction. So hopefully this video makes it clear what CQRS is all about. What are the main takeaways? Well, first of all, if you are talking about CQRS with your colleagues, make sure that you're talking about the same thing. Are you talking about the architectural principle, or are you talking about your code? And second of all, make sure that you're not building just some kind of weird CRUD separation thingy. If you are using CQRS, make sure that you actually are using commands and queries and not just CRUD operations disguised as commands. All right, that's it for this one. If you have any additional questions, you can put them in the comment section. If you have your own frustrations or are confused about certain things and you want to see it discussed right here on the channel, leave a suggestion in the comments, and I'll see you the next time. Bye bye.